cool the planet? Geoengineering is easier said than done. With the world facing increased warming, melting ice caps, rising sea levels, intense weather events and other global disasters, scientists are exploring ways to re-engineer the planet to counter the effects of global warming. Earth's surface has warmed, on average over land and sea, 1.53 degrees Fahrenheit, 0.85 degrees Celsius, since 1880, according to the Intergovernmental Panel on Climate Change, an international organization created by the United Nations to evaluate the state of climate change science. Changing Earth, 7 Ideas to Geoengineer Our Planet, in the most recent issue of the journal Science, published online Thursday, July 20. 2 researchers provided perspective on 2 geoengineering methods that could reduce the so-called greenhouse effect, under which gases and clouds in Earth's atmosphere trap the sun's heat. Both schemes could contribute to a cooler climate, but they are not without risks. And as both researchers made clear, neither idea addresses the rising levels of carbon dioxide, CO2, in the atmosphere that is primarily to blame for global warming and higher levels of oceanic acid. This acidity is killing the coral reefs that shelter marine life and support the fish that humans eat. Ulrich Lohmann and Blaž Gasparini, both researchers at the Institute of Atmospheric and Climate Science ETH Zurich in Switzerland, proposed a counterintuitive plan: seed the upper atmosphere with tiny particles of desert dust to reduce cirrus clouds. These are the wispy, nearly invisible clouds that form at high altitudes. Unlike fat, billowy clouds that reflect sunlight, these clouds trap heat energy radiating up from Earth out into space. If cirrus clouds behave like a blanket around the Earth, you're trying to get rid of that blanket, Lohmann, a professor of experimental atmospheric physics at ETH Zurich, told Live Science. Thinning the clouds, seeding the atmosphere with dust would paradoxically thin out cirrus clouds, Lohmann said. Under normal circumstances, the atmosphere at altitudes of about 16,000 to 40,000 feet, 4,800 to 12,200 meters, is full of tiny particles. Some are solid particles like mineral dust, and some are liquid aerosols, such as sulfuric acid. The liquid aerosols freeze instantly and create ice crystals that form long-lasting cirrus clouds. Cirrus thinning changes this dynamic, Lohmann said. The idea, Lohmann said, is to inject solid particles, like desert dust, into the atmosphere at spots slightly lower than where cirrus clouds would naturally form. The quantity of dust introduced would be far less than the number of particles that exist higher up. This part is key, because fewer particles will attract more water vapor, creating larger crystals. As the ice crystals grow to larger and heavier, they would then fall as precipitation, and depending on the conditions would evaporate before reaching the ground. You remove the water vapor, you remove the humidity and you prevent the normal cirrus cloud formation, Lohmann said. 8 ways global warming is already changing the world. Ideally, the method would be applied to locations most susceptible to cirrus cloud formation, Lohmann said. Geographical latitudes above 60 degrees, including the Arctic, where temperature increases from CO2 are the greatest. The researchers' computer models have shown that if done correctly, cirrus thinning could reduce global temperatures by 0.9 degrees Fahrenheit, 0.5 degrees Celsius, Lohmann said. But if done incorrectly, the activity could produce cirrus clouds where none existed before, contributing to the very problem it's meant to solve, she added. Risky business, the risk of doing more harm than good is a concern, said Ulrich Niemeyer, a climate scientist at the Max Planck Institute for Meteorology in Hamburg, Germany, and her colleague Simone Films, a project scientist at the National Center for Atmospheric Research in Boulder, Colorado. Niemeyer and Tilms published a separate commentary in this week's issue of the journal Science that discusses a geoengineering method called stratospheric aerosol modification, SAM. SAM involves injecting sulfur aerosols into the stratosphere to increase the reflectivity of Earth's atmosphere. Computer models have shown that SAM could reduce the amount of sunlight that reaches the planet's surface. The effect would resemble that of ash clouds that linger after volcanic eruptions, which have been shown to lower global temperatures, the researchers wrote. But the science behind SAM is in its very early stages, and the technologies to deploy it are not developed, the researchers added. It was our intention to say that geoengineering is not something that we should have in the back of our minds as the main solution, Niemeyer told Live Science. Niemeyer and Tilms wrote that different computer models consistently identify side effects to SAM. For example, reducing incoming solar radiation also reduces evaporation, which in turn reduces precipitation, and that can slow the hydrological cycle, particularly in the tropics, the authors wrote. Less rainfall can increase droughts that are already devastating parts of the world. Although computer models tend to agree that it's best to inject the aerosols into the stratosphere above the tropics or subtropics, and that the aerosols would disperse globally, the models differ on the extent of injection required for a given level of cooling, the authors wrote. Most current Earth system models do not adequately capture important interactions, such as the coupling between stratospheric aerosols, chemistry, radiation and climate. They cannot, therefore, simulate the full impact of the interventions, Niemeyer and Tilms wrote. Complicated solutions. Even if scientists could figure out a precise method, the economics are mind-boggling. Using SAM to bring down global temperatures just 2 degrees Fahrenheit, 1 degree Celsius, to pre-industrial levels, would require injection amounts equivalent to 1 volcanic eruption per year the size of the 1991 Mount Pinatubo blast in the Philippines, the largest volcanic eruption in the last 100 years, according to the U.S. Geological Survey. The cost of dispersing that much content artificially would cost $20 billion per year and require 6,700 aircraft flights per day over 160 years, the researchers wrote. No single method can solve the climate change problem as a whole, either, they said. Any geoengineering method we know of can only offset part of the global warming that we have, Lohman said. And no method designed to cool the planet deals with the gases in the atmosphere that are the sources of the problem and are contributing to increasing levels of acid in the oceans, the researchers said. It doesn't get at the heart of the problem, Lohman said. The ocean acidification is ongoing. If society decides to undertake any geoengineering method, she said, this action should be accompanied by large efforts to reduce greenhouse gas emissions. Niemeyer said emission reductions should be the primary focus. We are quite critical about geoengineering, and we want people to be aware it would be a difficult,